So far, our study of trigonometry has dealt with triangles, in particular right triangles, and when we've talked about measuring angles in a triangle, we've always used degree measure. And there's a reason for that. Using degree measure is a very nice way to measure angles when we're dealing with triangles. However, now we're going to transition over to focus more on central angles in a circle. And when we talk about those types of angles, many times we'll find it more convenient to use a different form of measure, and that's what we're going to look at today. I'm talking about radian measure. So first of all, I want to define for you what a radian is, and then we'll look and see, well, what is the relationship that radians and degrees have? So how are they related? So first of all, let's consider a circle here. Now, I've drawn this circle using a sketch pad so that this radius, the length of this radius, and the length of this arc from CB, so the segment AB and the length of CB, those lengths are the same. Now, that's important to realize that these lengths are the same. So this arc length is the same as this radius length. Now, I'm going to call this angle theta. And notice it has a terminal side, AB, and then of course that angle theta is formed by coming from this initial side and rotating counterclockwise, theta units. Now, what I want to point out is this. When this happens, when this arc length is the same as this radius length, we say that that angle formed, this central angle, we say is 1 radian. So that's what a radian is. A radian is the central angle. It's the measure of the central angle that subtends an arc that is the same length as the radius. So this is 1 radian. Okay? It's the central angle that subtends the arc that's the same length as the radius. Okay? So this angle is formed, so it's 1 radius, or 1 radian. Now, let's suppose that we go twice the distance, so that now this arc is 2 radius lengths. Now, we still have an angle formed. Notice that this terminal side AB is the result of rotating counterclockwise from the initial side here, which is the axis. So we get a theta, an angle theta, and because this is 2 radius lengths, this angle that subtends it would be 2 radians. So we would say that theta in this case is 2 radians because it subtends 2 radius length arcs. So now let's look at next. Let's suppose that we talk about rotating. Notice we went 1 radian earlier, then 2 radians. What about if we go all the way and make a half circle? Well, if we do that, we'll find that theta is exactly pi radians. You see, if you talk about, well, how many radius length arcs are in a half circle? Well, you would get 1, and then 2, and then 3 would be just short of a full half circle. The fact is, you would get exactly pi radius length arcs on half a circle. So we would say that 180 degrees, of course, if we're thinking of in terms of degrees, this theta would be 180 degrees, which corresponds to pi radians. Now, incidentally, that's why we say that if you want to calculate the circumference of a circle, it's 2 pi times the radius, because you take Well, how many radius lengths are there? Where there's 2 pi of them, and then if you know the radius, you can get the circumference. But now let's look at some implications here. So we know that pi radians is 180 degrees. Now, what if we, of course, and I've already said this, but what if we multiply both sides by 2? Then we get 2 pi radians is 360 degrees. Likewise, if we divide both sides by 2 here, we get pi over 2 radians equals 90 degrees. And if we divide both sides by 4 up here, we get pi over 4 radians is 45 degrees. So that's just some implications that arise from recognizing that pi radians is 180 degrees. It corresponds to 180 degrees. But what we want to do is we want to be a little more general. And we want to look and say, well, how do you convert from radian measure to degree measure? If you know how many radians you have, how can you calculate how many degrees that is? So let's start by recognizing that pi radians is 180 degrees. Now I'll do this. I'll divide both sides by pi, and we find this, that 1 radian equals 180 degrees over pi. So that's 1 radian. Now, this is the relationship we're going to use, because since we have this relationship, we can answer the question, what about 2 radians? Well, let's see. I've got 1 radian equals 180 degrees over pi, so just put a 2 in, multiply both sides by 2, and we get 2 radians equals 360 degrees over pi. And you can see that I could have easily have chosen anything. I could have said, well, what about 5 radians? And substitute a 5 in for the 2. But we'll just be general and say, in general, for k radians, here's the relationship. K radians equals k times 180 degrees over pi. Now, what that gives us is the ability to convert. Anytime we know how many radians we have, we can multiply by 180 over pi and find the degrees. Now let's go the other way. Let's go from degree to radian measure conversion. Okay? So we start off with, once again, that 180 degrees is equal to pi radians, and now I'll divide by 180, and I get that 1 degree is pi radians over 180. So we ask the question, well, what about 2 degrees? Once again, I multiply both sides by 2. And I get that 2 degrees equals 2 pi radians over 180. And you can see that in general, for k degrees, we have k degrees equals k times pi radians over 180. So this is what we want to multiply by. If we know how many degrees, if we are given degrees and we want to convert to radians, just multiply by pi over 180. Now, a couple of examples. Convert 12 degrees to radian measure. Okay? So notice I just multiplied 12 times pi over 180, and notice that the 12 goes into 180 15 times. We're left with the pi on top, so that's just pi over 15 radians. Okay? So that's converting degrees to radian measure. Now, what about radians to degrees? Let's convert pi over 10 to degree measure. So we use our relationship here. Pi over 10 radians equals pi over 10 times 180 over pi degrees. Notice the pi's divide out. 180 divided by 10 is 18. So we have 18 degrees.